In our last activity, we looked at some of the discoveries that led us to believe what's going on with the atom, and today we're going to be talking about the structure of these atoms. And so here on the screen we have a picture of what an atom would look like, kind of stylized, but nevertheless it's good. It's a helium atom, and so we're going to be talking about these different particles that were discovered by the various experiments that you read about and created that Google Slides presentation for. And we're also going to talk about how to calculate using the periodic table the number of protons, neutrons, and electrons an atom has. So let's get right to it. Okay, so as we saw in our last activity, we talked about there's basically three subatomic particles. There are other subatomic particles within an atom, but we're only going to talk about the three basic ones. The first off is we have a proton, and protons are positively charged particles. Oftentimes when we talk about protons, we'll just kind of use the symbol P with a plus sign to show that is a proton that we are talking about, positively charged proton. Protons are positive. Okay. The next one is an electron, another subatomic particle. These guys are going to be negatively charged, and oftentimes we just show this by using an E with a negative sign. And we also have a neutron, which is our neutral particle, and an N with a 0, just showing that it is a neutral particle. Now we also need to bring up the idea of the nucleus. The nucleus in chemistry is different from the idea of nucleus in biology. In biology, we talk about the nucleus being the location of the DNA, but in chemistry, we talk about the nucleus being the location of our protons and our neutrons. So protons and neutrons located in the nucleus. So let's kind of scroll back up here and take a look at our diagram. And we can see here that we have our neutrons here, and we have our protons here. So this location, all of these guys right here, would be considered the nucleus. It's the nucleus. And because you have positively charged protons and neutrally charged neutrons, we say that the nucleus is positive. Just the nucleus itself is positively charged because of those protons. There's nothing there to kind of cancel out the positive charge. The nucleus is also, and this is very important and you should jot this down, the nucleus is also accounts for most of the mass of an atom. And we talked about in our presentation previously how if we assign particles a relative mass, we would say that the positively charged protons have a relative mass of 1 AMU, and the positively charged neutrons have a mass of 1 AMU, and the electrons have a negligible mass, very small. And so the electrons, when you lose or gain electrons off of an atom, really doesn't affect the mass. When we lose neutrons, it definitely does affect the mass. And if we change protons, we're going to find out soon that changes who the atom is. So really the takeaway here is that most of the mass in the atom comes from the nucleus, and it's positively charged. We also say it's very dense. Scroll back down here. So again, the nucleus is the location of the protons and neutrons. And something we also need to add in here is what we call an electron cloud. This is going to be our location of, obviously, electrons. And we like to describe it as a cloud. And we'll scroll back up here. Now, oftentimes atoms are shown with electrons having this fixed orbit around the positively charged neutron, or nucleus rather, and that's not necessarily 100% correct. We like to say that they're a cloud. So these guys, they're showing the electrons in this picture about equal distance from the nucleus, which is really not accurate. We would say that electrons can be found in a certain area, and they can be found anywhere within this area. So you might find an electron in here, you might find an electron a little bit outside here, anywhere in this area, and moving really, really rapidly, not necessarily in fixed orbits like the moon being in a fixed orbit around the Earth, but more they're located sometimes here, sometimes here, sometimes here, sometimes here. It just depends. They're moving really rapidly. Okay, so that's what we like to call an electron cloud. And one other thing that we need to keep in mind here is, let's say in this helium nucleus, when we only have 2 electrons in the helium nucleus, this is a lot of empty space. empty space where the electrons are not. And we think of it like a ceiling fan. A ceiling fan, when it's moving really, really rapidly around, you've got it on the maximum speed for a ceiling fan, there's a lot of empty space, but when you look at a ceiling fan, it actually looks like it's a continuous, solid object. We can think of the atom much very similar to that. Let's talk about a couple more things. Let's talk about the idea of atomic number and the idea of average atomic mass. And you're going to need your periodic table out for this. Now, if we look at the periodic table, and I'm just going to pick an element off the periodic table. We noted on the periodic table that all the elements have their own little cell here. And let's say we take an example of like lithium. Lithium has a couple numbers associated with it. Okay, there we go. So the first one is this number up on top here is what we call the atomic number. And so let's define what an atomic number is. Atomic number is going to be the number of protons in the element. So we would say that lithium has 3 protons. That's easy enough. We can also say, and let's scroll this down just a little bit, that the atomic number is equal to the number of electrons in a neutral element. So if this was a neutral lithium atom, we would say that it has 3 electrons as well, because the atomic number is 3. Now, we'll find out very soon that not all atoms are neutral, and so that's going to change, but we'll get to that too. We'll get to that later. And the average atomic mass is a weighted average. A weighted average. And what we mean by a weighted average is we mean something very similar to how we weight your grades in this class. And so if you're in chemistry class with me, 55% of your grade is tests, quizzes, and projects, and 20% of your grade is labs, and 10% is classwork and homework, and 15% is the final. So we average the different isotopes' mass, and so we'll talk more about that in the coming days. But let's say right now this bottom number is equal to the number of protons plus the number of neutrons, because remember, the protons and the neutrons are what accounts for most of the mass of the atom. Okay, so if we want to calculate some things, we can do so. So let's keep that in mind. So now what we want to talk about is how to calculate this number of protons, electrons, and neutrons in an atom, which we've kind of alluded to for the protons and electrons already. And so we'll pick a different atom. Let's say nitrogen. Oops. Let's back up there real quickly here. And let's pick nitrogen on the periodic table. Nitrogen on the periodic table has the symbol of N, atomic number of 7, average atomic mass of 14.0. So if we were being asked to calculate the number of protons, electrons, and neutrons in nitrogen, it would actually be pretty easy to do. So remember, our atomic number is this number on top. That's going to be equal to the number of protons. So we'd say the number of protons is 7 in nitrogen. Now, if nitrogen is neutral, then that's also equal to the number of electrons. So we'd say nitrogen has 7 protons, 7 electrons. Now, what we do for the number of neutrons is we're going to go ahead and round off to a whole number the average atomic mass. So the average atomic mass in this case is basically rounded off for us already. We have 14. And then we're going to subtract the atomic number. Now, the reason why we do that is this. Remember that the average atomic mass are going to be our number of protons plus the number of neutrons. And the atomic number is just the number of protons. So if we subtract those, that gives us our number of neutrons. So obviously we subtract 7 from 14, and we get the answer of 7. So in this case, all the number of protons, electrons, and neutrons in this neutral atom all came out the same, but that's not always the case. So let's do one more just as a practice. And if you would like, after I write down the problem, you can pause this and work it yourself and see if you get the same answer as I get. Okay? Okay, so here's our example. How many protons, electrons, and neutrons are in a neutral atom of iodine? Okay, so if we look up on the periodic table for iodine, iodine has the symbol of capital I, and it has 53 as its atomic number, and 126.91 is its average atomic mass. So number of protons, obviously the number of protons is equal to the atomic number, so we have 53 protons. Because this is a neutral atom, we're going to have the same number, 53 electrons. And then to calculate the number of neutrons, what we're going to want to do is we're going to want to round off our average atomic mass, which is going to be, we have 126.9, which will round off to 127. And then we're going to subtract 53, which is the atomic number, so the average atomic mass rounded off, and we get 74. So we have 74 neutrons. So 53 protons, 53 electrons, and 74 neutrons is the composition of iodine, each iodine atom. And you're probably noticing every single time we change the number of protons, we change who the atom is. So if we were to add one more proton, let's say we added one more proton to an element that had 54 protons, we could then look that guy up on the periodic table, and it would be whoever has 54. And if we look that up, it would be xenon. And that has 131.29. So that's another way to take a look at those things. Okay. So a quick review of what we did today. We talked about atoms, and we talked about electrons being located in their electron cloud, which is mostly empty space. We talked about protons, which are positive, and neutrons, which are neutral, all located in the nucleus. And we talked about how to calculate the number of protons, neutrons, and electrons. And this number up on top is our atomic number, the number of protons. This number on the bottom is the average atomic mass, the number of protons plus neutrons. And we can subtract those two to get the number of neutrons. And if it's a neutral atom, it's going to have the atomic number equal to the number of electrons. Only works though with a neutral atom.